Hi everyone, today I'm going to teach you how to solve a system of equations by substitution. So as a reminder, a system of equations is two or more equations with two or more variables. So for these, we're going to just work with x and y, and when we have two variables, x and y, we're going to have two equations to help us solve. So to substitute means to replace. So for all of these, we're going to replace one variable with an expression of another. So for this first example here, 2x plus 2y is equal to 10, and y is equal to 5 plus x. Well, y is equal to 5 plus x, so I'm going to rewrite 2x plus 2, but instead of y, so I'm going to take this first equation and I'm just rewriting it. 2x plus 2, 5 plus x, since that's what y is equal to, equals 10. And now I can more easily solve for x since my equation only has x in it. So I'm going to distribute that 2. So now I have 2x plus 10 plus 2x is equal to 10. Combining like terms, 4x plus 10 equals 10. If I subtract 10 from both sides of my equal sign, I have 4x is equal to 0. And dividing by 4 from both sides, x is equal to 0. But I'm not done. Now that I know what x is, I can plug it in to the second equation, just easily solve for y. So y is equal to 5 plus x, in this case 5 plus 0, so y is equal to 5. So the solution is 0, 5 as a coordinate point. When we graph both of these equations, y is equal to 5 plus x and 2x plus 2y is equal to 10, they're going to intersect at the point 0, 5. For the second equation, or the second problem, we have 2x minus y equals 3, and x is equal to negative 2y minus 1. Well, since I know what x equals, I'm going to replace x. So I have 2 times negative 2y minus 1, because that's what x is equal to, minus y equals 3. So all I'm doing is rewriting the top equation, making it look a little bit different so that we only have one variable. I'm going to distribute my 2. So negative 4y minus 2 minus y equals 3. Combine my like terms, negative 5y minus 2 is equal to 3. If I add 2 to both sides, I have negative 5y is equal to 5. Divide by negative 5 to isolate y, and I get y is equal to negative 1. Now I can plug y in for my x equation so I can easily solve for x. So x is equal to negative 2 times y, in this case negative 2 times negative 1 minus 1. X is equal to 2 minus 1. X is equal to 1. So if I were to graph both of these equations, both of these linear equations, they would intersect at the point 1 comma negative 1, so that is my solution point. Now the next one says that x is equal to y, so because both variables are already isolated, it's 1x is equal to 1y, I can decide to replace either one, to substitute either one. I'm going to choose y. So instead of x minus 3y is equal to negative 1, I'm going to say y minus 3y is equal to negative 1. Combine my like terms, y minus 3y is negative 2y equals negative 1. Divide both sides of my equal sign by negative 2. Y is equal to positive 1/2, which means that x is equal to positive 1/2. So my solution set my solution point rather is 1/2 comma 1/2. When we graph both of these lines, they're going to intersect at the point 1/2, 1/2. And the last one here, y is isolated, y is by itself. We know that y is equal to x plus 1. So I'm going to rewrite my top equation, x minus 2 instead of y. I'm going to write x plus 1. And I need to put the parentheses because I need to make sure that x plus 1 is coming as a package deal, because that's what y is equal to. Y is equal to x plus 1, not just x, not just plus 1. Because then I need to remember to distribute that negative 2. X minus 2x minus 2 is equal to negative 3. X minus 2x is negative x minus 2 is equal to negative 3. Add 2 to both sides. I have negative x equals negative 1, so x is equal to positive 1. To solve for y, I can plug x in. Y is equal to 1 plus 1. Y is equal to 2, which means that our solution point is 1, 2. Those are just 4 examples. Let me know if you want to see anything else below.